In this video, we are going to do a word problem associated with exponential. So we're going to have an exponential growth or decay kind of a situation, and we're going to plug it in and see what we got going on. So it says an exponential equation for the breakdown of a particular drug in the human body is this equation. So it very much has this kind of a feel where this is your multiplier, your rate, and then time, which represents how many times something's compounding. And then this was an initial value, and this is what you're going to get in the end. So same feel, they just kind of use D for drug. So this represents your initial amount, and then there's a rate, and then you have a period of time, and here's what the drug is after that amount of time. So it says where D is the amount of drug in the bloodstream after a specific amount of time. Okay, so here's what's left over at a certain amount of time. D naught is the initial amount of drug in the bloodstream. R is the decimal equivalent of the rate of change, so just a rate. And T is the amount elapsed of the elapsed time. So a certain drug breaks down at a rate of 15% per hour for the first 24 hours. Okay, so question is, find the amount of the drug in the bloodstream after 2 hours if the initial amount was a 9 milligram amount of medicine. So let's put some of the pieces together. So in order to do this, we need to know what the initial amount was, which they tell us, and it was 9. Our rate. Now our rate is breaking down. So our rate is going to be a negative 0.15. Okay, if something is going up, then it's going to be a positive, and so we're going to be adding that rate. But since this one it's breaking down, that means it's decaying, we are going to be subtracting our rate. So I just think of rate as a positive or a negative, and the math kind of takes care of itself if it's going up or going down. And then our amount of time is 2 hours. Okay, so D equals 9 times 1 minus, and raised to the second power. So we're losing 15% twice. So our look is 9 times 1 minus 0.15 raised to the second power. So after 2 hours, we would have left of medicine 6.5025 milligrams. So 2 hours would be 6.5025 milligrams left. All right. And then after approximately how many hours will the amount of the drug in the bloodstream be less than 1 milligram? So we are looking at setting our equation equal like this. 1 equals 9, 1 minus 0.15 raised to a power. All right, so there's a mathematical way to do this, which would involve logs, but you can also really kind of just look at a graph. So you could take this side of the equation, not look at a graph, but look at a table. So we're going to take a look at this side of the equation. So we're going to type this in, all right, and then we're going to look to when it about hits 1. So here's what I mean by that. So if you go into your y equals, clear out whatever equation you have, and we're going to do 9 times 1 minus 0.15, close your parentheses, raised to an unknown amount of time. And then if we look at our table, okay, let me scroll this down a little bit. Okay, so that represents the initial amount. You had 9 milligrams. And then over time, it started to go down. So we did the 2 hours, which was the 6.5025. And then we're basically just scrolling down to see when it's less than 1. So there you go. So at the 14th hour, somewhere between 13 and 14 hours, that's when it's going to be less than 1. And that's a very quick, and it's not a perfect, but it definitely, we're getting approximately how much time. And that is our approximate way of doing it. Okay, so we're looking at this way, about 14 hours. Okay, and so that was a little bit of an introduction to kind of some word problems associated that are not always just financially related, but this is something else, and this one was specifically related to decay.